Hello class, welcome to the second subtopic 1.2, which is arithmetic sequences, also known as arithmetic progressions. So whenever you read this word or this word, sequence or progression, they mean pretty much the same. They mean the same, and I'm going to use them interchangeably. And we're going to start easy today. We're going to start with a very few concepts because due to these reasons of the power shortage that's happening right now, I don't want to go too much ahead. So we're going to just look at these three things. The definition of this concept, some of its features, or well, rather all of its features or characteristics, and a specific formula. So let's start. So first of all, guys, what is an arithmetic sequence? It's the following. Well, first of all, let's define what a sequence is, because we can have many sequences which are not arithmetic. So let's first talk about this concept of sequence or progression. A sequence is just this, guys. It's a list of numbers, one after the other. For example, if I write 2, 5, 7, 13, 19. I can stop right here. This is just a sequence or a progression. And what that is basically a list of numbers with some order. Okay, the concept of order is extremely important in a sequence. Okay, this sequence. In this sequence, the first term, we say this word term. The first term is 2, the second term is 5, the third term is 7, the fourth term is 13, and the fifth term is 19. So this is a sequence. It's just a list of numbers in which the order of the terms is important. For example, if I wrote this other sequence, you see, I have the same numbers as before. Can you see? But now they have different orders. Now my first term is 5, my second term is 2, my third term is 7, my fourth term is 19, and my fifth term is 13. So this other sequence is different than this other because the order of each of the terms is different, and that's enough to make these two sequences different. So the order is very important, not just what terms does it have, but each of the order of the terms. So that's a sequence. It's just a list of numbers, and they can be random or they can have some property. For example, let me tell you about one of the most famous sequences in the history of mathematics, which perhaps you know by now. Suppose that you have a sequence and you build it in this way. You start with the first term being 0, and then the second term being 1. And then the rest of the terms of this sequence are going to be constructed by following a certain specific rule. For example, each new term in this sequence is going to be the sum of the two previous terms. So this term in here, in specific, this one, will be the sum of the previous two terms, which is 0 and 1. Let's add them. 0 plus 1 is 1. There you go. Now, the next term in this sequence, which is right here, should be the sum of the previous two terms, which is 1 plus 1, which is going to be 2. And the same for the rest of them. This new term is going to be the sum of the previous two. 2 plus 1, 3. This one is going to be 3 plus 2, 5. The seventh term will be 5 plus 3, 8, etc., etc., etc. So this sequence, guys, is what we know as the Fibonacci sequence. I don't know if you have heard that name before. The Fibonacci sequence, 0, 1, 1, 2, 3, 5, 8, 13, blah, blah, blah. Okay, this is a very important sequence in mathematics, a really, really important sequence, and it appears in many, many places in nature. It appears in flowers, you know, when you have the petals of the flowers, these numbers, the number of petals, I suppose that's what the name is, petals, petalos. The number of petals in a flower is usually a number in this sequence, usually, very, very common. And you can see it in many other places. So this is a very important sequence. Okay. What other type of sequence can we have? For example, what about this sequence, guys? What about this sequence? 0, comma 1, comma 4, comma 9, comma 16, comma 25, etc. So what is the property that each of these numbers is following? Is there any pattern or any rhyme and reason? Yeah, right. Each of these terms in this sequence is actually the square of an integer, of a natural number. 0 is the square of 0, 1 is the square of 1, 4 is the square of 2, 9 is the square of 3, 16 is the square of 4, etc. So again, here we have some pattern. But I don't want you to get confused and have the idea that you should always have a pattern in a sequence. A sequence can be any list of numbers. It doesn't matter. I can write 3 minus 1, 1/2, the square root of 2, 5/7, and I can just stop right here if I want. And this is a perfectly good sequence, even though you cannot find any pattern behind it. This is a perfectly good sequence, just as the previous ones. Okay, so that's a sequence, guys. It's just a list of numbers in which the order is important. Now we have two types of sequences, basically, in regards to how lengthy they are. We have finite sequences, and we also have infinite sequences. And what this means is the following. It's a very simple idea. A finite sequence is when you have a finite number of terms in the sequence. For example, if I write this, 1, 4, 9, 16, and I stop. So this is a finite sequence because it only has 1, 2, 3, 4 terms, and that's it. It stops. We don't have an endless amount of terms. It just stops. So that is a finite sequence. Now, an infinite sequence is one that goes on forever. For example, following the same example that this was following, which is the square of the natural numbers, I can write 1, 4, 9, 16, 25. And then when you read these 3 points in mathematics, it means the same as in everyday life or in everyday in literature. It means and so on forever. So this other sequence is an infinite sequence because the number of terms is boundless or endless. It goes on forever. This is a finite sequence. This is an infinite sequence. Okay, so now we know what a sequence is. It's just a list of numbers, each of which has its own place in the sequence. And they can be either finite or infinite in regards to the number of terms that they have. Okay, now that's a sequence, guys. That's just a sequence. Now, what is an arithmetic sequence? Okay, an arithmetic sequence is a sequence in which the following happens. Take a look. Okay, let me stop right here. I have written a sequence, a finite sequence, because I'm stopping. I'm saying that this sequence only has 5 terms. Perfect. Now, what is the pattern behind this sequence, guys? Can you see a pattern? It's very simple. Each of the new terms in the sequence is actually the previous one plus a specific number, right? For example, 5 is actually 2 plus 3, and you get 5. Now, 8 is the previous term, which is 5, plus 3 again, and you get 8. And the same goes for the rest of them. 8 plus 3, 11, 11 plus 3, 14, and now we stop. So as you can see, each new term in the sequence is obtained following that precise rule. And that rule is this. Look at the previous term, add a specific constant determined, and you will get the next term in the sequence. So when this happens, when your sequence has this property, this is what we know as an arithmetic sequence. That is the defining property of an arithmetic sequence. Let me give you another example. What about this, guys? Let's start with 10, and then we have 15, 20, 25, 30, etc. So what type of sequence is this? In regards to the number of terms, this is an infinite sequence because I'm seeing the 3 points, which means and so on. So this is an infinite sequence. Now, is this an arithmetic sequence? Well, if this is an arithmetic sequence, it must have this property. Each new term in the sequence must be the previous one plus a specific constant. So what constant should that be in this case? It's going to be 5, right? It's very simple to see. 10 plus 5 is 15, 15 plus 5 is 20, and so on. Okay, so this is also an arithmetic sequence. This is an arithmetic sequence. This is also an arithmetic sequence. What about this one? 3, 1, -1, -3, etc. Look at this. Again, this is an infinite sequence because I'm seeing the 3 points. Now, is it arithmetic or not? The answer is yes. What is the number that we are adding constantly in order to get the new term? We are adding the number -2. Okay, so it can be either a positive number or a negative number. 3 plus -2, we get 1. 1 plus -2, we get -1. -1 plus -2, we get -3, and so on. One final example. What about adding a fraction now? What if I have this? 1, and then we have perhaps 3 halves, and then 2, and then 5 halves, and let's stop right there. This is a finite sequence of 4 terms, and what is the number that I'm constantly adding to get the new one? Think a little. I'm adding 1/2, right? 1 plus 1/2 gives me 3 halves. 3 halves plus 1/2 gives me 2. 2 plus 1/2 gives me 5 halves, and then we stop. So as you can see, this constant that we are constantly adding to produce the new terms can be either positive numbers, negative numbers, fractions, whatever. There are no restrictions upon this number that I'm constantly adding to produce the new ones. There are no restrictions. It can be any number whatsoever. Okay, so that's an arithmetic sequence, guys. We started with a sequence, and then we explored the concept of finite sequences, infinite sequences. Now, the concept of arithmetic sequences. Those are the ones that must follow a specific pattern. Let me give you a counter example. Of something that, even though a sequence, it's not an arithmetic sequence. For example, what if I wrote this? This is a sequence. This is a finite sequence. And if you try to answer the question, is this an arithmetic sequence? You will have to answer no. Why not? Because at first it resembles an arithmetic sequence. 1 plus 2 gives me 3. 3 plus 2 gives me 5. 5 plus 2 gives me 7, but then we have this jump of plus 3. 7 plus 3 equals 10. And even if just in one occasion the rule is broken, in this case plus 2, then this is not an arithmetic sequence. The constant that we are constantly adding to produce a new term must be always the same. We cannot have something like this. So this is not an arithmetic sequence. It's a sequence, fine, but it's not an arithmetic sequence. Okay, very good. Now, let's explore the idea of the features of a sequence. What about the features? There are three main features in any sequence, guys. Let me write this sequence. Okay, so this is an arithmetic sequence, right? Because I'm constantly adding what number in this case? I'm constantly adding plus 3, right? In order to produce the new terms. So this is an arithmetic sequence. And I'm going to define three important features of any arithmetic sequence. The first feature is this, what we know as the first term in the sequence, the first term. And it's usually represented by u sub 1 or just u1, u1 or u sub 1. And it's clearly the first term in the sequence, the first one that appears. In this case, u1 is 2. This is my first term in this particular sequence. Next feature of any arithmetic sequence is the difference, represented with a d normally. What is the difference? Well, it is that precise constant that we are adding over and over again in order to produce the new term in the sequence. So in this case, the difference, my d, is going to be 3 for this particular sequence. And then we have a little more complicated concept, which is known as the nth term. This is even hard to pronounce. U sub n, the nth term. I'm going to repeat that, the nth term. Okay, what is this? The nth term is just any general term. For example, if this is my first term, this is my second term, this is my third term, this is my fourth term, this is my fifth term, and then we can continue in this way, and then we can have any general term which we may call the nth term, el término enésimo. This is an abstract concept which is understood more by example than by trying to define in words what this means. The nth term is basically the term that would occupy the place n. You see? I'm going to repeat that now in Spanish. El término enésimo de una secuencia es simplemente aquel término que ocuparía el lugar número n. That's what the nth term means. In this case, the n acts as a placeholder. It's a placeholder. Okay, so that's basically, by the way, it's represented by un, and these are the most important features of any arithmetic sequence. The first term, denoted by u sub n or just un, the difference, and the nth term. Okay, fine. Now, the first important formula that we're gonna get to know in regards to these sequences is the formula that will give me the nth term of an arithmetic sequence if I know if u sub 1 and d are known. So suppose you have a sequence, guys, and you know the first term and you also know the difference. And then I ask you, what's gonna be the term of number n? Let me give an example of what I mean by this. Suppose we have this. We have the sequence 4, 7, 10, 13, etc. So this is an arithmetic sequence because we're constantly adding plus 3 one more time. As you can see, this is my first term, this is my second term, my third term, my fourth term, and it goes on forever. Now, what if I ask you guys, what's going to be the term of order 107? What's going to be this term? Can we find a formula to find very quickly what number this is going to be if we know its place? Okay, the place of the 4 is place number 1. That's why it's the first term. Second term is 7, etc. So what term should be here for the term 107? What number should be here? You see, that's what we mean by the nth term. It's basically trying to get a formula to get that position for any other number. I might as well have asked you about the term 211 or whatever. So basically what I want to do is ask this question. Can I write a formula to get immediately the nth term, the term that goes in the place n? Can I get this number quickly by a formula? If I know this, the first term, and if I know the difference. Okay, let's see. Yes, it's possible. And maybe I want to do that with you in real time. Let me see how much. Okay, let's stop right here.